So there's a question here that says, what does it mean to solve a quadratic equation? But I could even just ask, what does it mean to solve an equation? Does anybody remember the answer to that question? What does it mean to solve an equation? There's different ways you might think about it, but you're going to get a number by itself, so that's one of the things that we're going to try to do. Actually, that's a really good point. We're going to do that in a second. What does it mean to solve an equation?
You would sub something into x.
Yeah, it has something to do with that. What happens when I sub in for x? So what does it mean to solve an equation? Find, in this case, it's x, but it could be another variable. Find the x that makes it true. There's two different ways that we look at variables. In a quadratic equation, x can be anything. X can be 1, x can be 2, x can be 3, it can be -10, it can be anything. I put it in and I find the y. If I put 10 in for this, I get 10 on the left side. 2 times 10 is 20 minus 12 is 8. I get 10 equals 8. But 10 does not equal 8. Does anybody in here think 10 equals 8? So 10 is not the right answer for x. Okay? So we're finding the x that makes this true. So let's go ahead and do this. This is linear. This is not what we're doing today. But this is what you've done a lot of already this year, and you do in grade 9 and that kind of thing. How do you solve a linear? And this comes back to what Zach said about, like, you get the number by itself. So you isolate. We call that isolating usually. So minus 2x and minus 2x. X minus 2x is negative x equals negative 12. Multiply both sides by -1 or divide both sides by -1, however you want to see it, and x equals 12. So I was close. I said 10. I was close because I could have picked any number. But it turns out x is 12. What does that mean? 12 makes the original statement a true statement. 2 times 12 is 24. 24 minus 12 is 12. So if I put 12 in for x here and 12 in for x here, I get the same thing on the left side and the right side, right? The left side, right side check, like you all remember that. Okay, but that's what it means to solve an equation. Find the x that makes it true. That's how you do it for linear. You isolate. How do I do it for quadratic? Let's try isolating. I could add 7x to both sides to get all the x's on one side, and I get x squared plus 7x equals -12. What do I do now? Is x squared plus 7x, is that 7x squared? Or maybe you think it's 7x cubed? Sarah? Well, that's what we're going to get at. But the whole point of this is, with quadratics, you can't isolate. Because usually you have an x squared and an x. And no matter how hard you try to mash them together, they don't fit together. Okay? They're not like terms. You can't add them together. It's not 7x anything. So Sarah said, don't you make it a trinomial? Yes, that's exactly what we're going to do. We're going to talk about one other thing before we actually start doing it. But solving quadratics is totally different from solving linear equations. Linear equations, you isolate. Quadratic, you can't isolate. So I'm going to write that down. Can't isolate. So we need another way of solving. And today there's different ways you can do it. Today we're going to solve by factoring. Everybody okay with that? Before we get to that, we're going to do a little talk. You can just watch. You can write this down if you like. I don't know that you have to. You might just want to watch. Okay? When you're solving a linear, the one we just did where you isolate, you get one answer. Okay? You always just get one answer. When you're solving a quadratic, there's three possibilities of what your answers will look like. And we can think about the three possibilities by looking at the graph of a parabola, which you talked about in grade 10, but if you're not sure where I'm going with this, bear with me for a minute. It'll make sense when we're done. Okay, so here's one possibility. This graph has two x-intercepts, so it has two solutions. This graph has one x-intercept because the vertex is right on the x-axis. So this one has one x-intercept, so it has one solution. And this one, how many x-intercepts does that one have? None, right? Like, and it never will, because it's never going to turn back. So this one has 0 x-intercepts, so it has 0 solutions. So it's interesting that in quadratics, sometimes you get a no solution. Okay? And what I want to say about this is solving a quadratic equation, or any equation actually, but we're going to talk about quadratic today. Solving a quadratic equation that is equal to 0. So something like x squared plus 7x plus 12 equals 0. That's an equation. Do you agree? That's an equation like we just saw above. Is the same as solving y equals x squared plus 7x plus 12 when y equals 0. Because all I would do is take 0 for y and plug it in for y. Do you agree that if I put 0 in for y, this looks like this? It's the same thing, right? And when y is 0, we have an x-intercept. Look back at those graphs. Where is it true that y is equal to 0? Here, which is on the x-axis. Y is 0 is an x-intercept. That's something, again, from grade 9, something hopefully we kind of know, but maybe we don't always think about it that way. So all we're doing today is solving quadratic equations by factoring. But in a few days, we are going to talk about graphs again. And there's this thing in mathematics, which is a kind of a big deal, where we use graphs to understand the algebra of what we're doing. But like what I'm saying is, you're going to be able to get through today without really thinking about it like that, but it can be helpful. So we like to talk about it anyway. Okay, so like we're not going to do anything else with x-intercepts today. We're just going to solve equations. But it's interesting that you could think about x-intercepts. It helps us visualize why sometimes there's two solutions, sometimes there's one, and sometimes there's none. Okay? Okay, very quickly, you probably want to write this down. Again, you've seen this before, which is awesome. It makes it that much easier. If you can factor, if you're very good at factoring, then this is really easy. The hardest part of this is probably the factoring part, right? Kind of have to remember what to do, but very rarely do people have an issue with that. It's the factoring that people have a hard time with, okay? So we use this thing called the zero product property. It only works for 0. It does not work for other numbers. And what does it mean? It means, consider this. If A times B is 0, what can I conclude? What do I know about A and B? Do I know anything? Sarah? One of them, or both, I guess, has to be 0. You tell me two other numbers that multiply to 0. How about 5 and negative 5? Does that multiply to 0? What is that? That's negative 25. It's not even close. Negative 5 plus 5 is 0. But when you're multiplying, that's why 0 is kind of a special number. 0 times anything is 0. And nothing else will multiply to give you 0. So we know that either A or B, of B, A or B or both must be 0. Because the only way to multiply to 0 I don't know that you have to write this down. The only way to multiply to 0 is with 0. Okay? So we use this idea to solve quadratics by factoring. And I have this big graphic over here. There's no 8 product property. And I have it because there's this question that came up in a class years ago where a whole bunch of people tried to do the same thing, but for 8. So like if this times this is 8, then either this is 8 or this is 8? No. What about 2 times 4? Like we don't know, like if it's not equal to 0, we don't know anything. This is a big deal because it's a common mistake. So when you are solving by factoring, you have to make sure one side is 0 because we're using the 0 product property. Seems obvious, but again, all of a sudden we start mixing up questions together and people make this silly mistake where they forget that it has to be equal to 0. Okay? All right. You don't worry about writing that down. It's just saying that to use the 0 product property, we have to factor first, because then we have something times something, because that's what factoring does. So let's get into this. Example 1, solve each quadratic equation. The first 2 are super easy because they're already factored. So this is just a demonstration of how we do the last step or 2 of these questions. Usually you'll have to factor first. Okay, so this is how we do it. Put your pencil down and watch. This is my A times this is my B. It's a bracket. A doesn't stand for a value. It's not like 3 times 2. Okay? A is this bracket. B is this bracket. This times this is 0. Therefore, with the 0 product properly, we can conclude either x plus 6 is 0 or x minus 3 is 0. Why is that funny? Okay. And then you have 2 little linear equations that you have to solve. These ones are super easy. I move the 6 to the other side, it becomes negative 6. Like I'm subtracting 6 from both sides. I move the 3 over by adding 3 to both sides, and I get x equals positive 3. So the signs flip, but you just move it right over, and then you're done, because now I have x equals something. I figured it out. Any questions so far? Too slow, too easy? How are we feeling about this? Let's try the next one. Here's my A. Here's my B. Either A has to be 0 or B has to be 0 for the whole product to be 0. Therefore, I can conclude 2x minus 1 equals 0, or 3x minus 4 equals 0. These ones require two steps because they've got a number in front of the x. So for this one, I move the 1 over, and it becomes positive. Then I divide both sides by 2. Yes? Then this one, I move the 4 over, and it becomes positive. Then I divide both sides by 3. And so sometimes we get fraction answers. If you said they kind of naturally turn into fractions, okay? So if you said 0.5 for this one, that would be fine, but that one's not going to be a nice decimal. So if you said 1.3 rounded, they're going to lose half a mark or something. It's not quite right. So fraction answers for these are better than decimals. But my rule is always, if it's an exact decimal and you prefer to write it that way, it's fine. If it's a rounded decimal, no good. Now here comes the good stuff. What's different about these questions? They're not written out like this times this. And this first one looks kind of like the question we looked at above, where I can't get the x squared and the x together. I cannot isolate for x. So the only way to solve these quadratics is by factoring. Can we factor this? What kind of factoring question is it? And don't forget, it's always got to equal 0. But these first 4, actually, they don't all. The first 3 do. It equals 0, so we're good. What kind of factoring? Simple trinomial. It's got 3 terms, so it's a trinomial, and it's simple because it's 1x squared. So I am looking for 2 numbers that multiply to 10. And because the 10 is negative, they have a difference of 3. What are they? Nice. 5 and 2. And the 5 is negative, so I get negative 5 plus 2 gives me negative 3. Negative 10 means, whoops, that should be a plus 2. Means they're different signs. And then negative 5 plus 2 is negative 3. But we're not done yet. Some people forget there's more steps now. Because you're so used to factoring, at least this happens in grade 10. We haven't been doing it as long, but in grade 10 you spend a ton of time factoring. And then when you add this, people forget there's a next step. So now I can say either x minus 5 is 0 or x plus 2 is 0. This is, just watch for a second. This is what I mean. Like if this said 8, there's no 8 product property. It's not either x minus 5 is 8 or x plus 2 is 8. You cannot solve this if it's not equal to 0. That's a big, big deal. That's why I'm making a big deal of it. Bring the 5 over. Bring the 2 over. Remember how I said a lot, like parabolas, quadratics can have 2 answers. 2 x-intercepts, 2 answers. Put your pencil down and think about this for a second. What if I said this was a quadratic, y equals that? Then the x-intercepts would be 5 and negative 2. The x-intercepts of that quadratic. Remember graphing quadratics in the last unit? Remember when we graphed them? So those would be the x-intercepts. But we don't need to worry about that today. Next one. So we're done, right? Because we've got x equals and x equals, so we're done. Next one. What kind of factoring question is it? Is it equal to 0? Yep, we're good on that. What kind of factoring question is it? Somebody else help me out here? Complex trinomial. Trinomial, and it's 3x squared. Very good. So we do our little chart off to the side. 1 and 3 and 3 and 1. And then 1 and 15 and 3 and 5. And don't forget to write equals 0 on every line. Some people just drop that and then add it back in at the end. Watch your signs. Are you adding or subtracting to the middle number? Three times 3 is 9, 1 times 5 is 5, and 9 minus 5 gives you positive 4. Okay, so I've got 1x and 3, and 3x and 5, and I want the 5 to be negative. So 5 times x plus 3 times 3, which is 9. But we're not done yet, because we're not just factoring, we're solving an equation. Therefore, x plus 3 equals 0, or 3x minus 5 equals 0. Everybody good? Any questions? All right, let's keep going. Negative 3 and 5 over 3. There's actually two ways to solve this one, so we're going to do them both. You pick your favorite. Some people are going to say one is easier. Some people are going to say the other is easier. One of them is by factoring, which is what we're doing today. So it's like, if you just always want to factor, then you just do this one by factoring. I'll talk about the other one when we get there. We're going to factor first. Okay, so you can solve this by factoring. What do you notice about this question? Okay, it's not a trinomial. It only has two terms. What else? Remember all the list of things we need to think about from yesterday when you're figuring out what kind of factoring question it is. What do we know about it? Brooke? No? Not sure? What were you going to say? Difference of squares. Very good, because there's two terms and there's a difference, but why is it not a difference of squares? Yeah, 2 is not a perfect square, and neither is 32. But this is how your brain should work. It should be like, oh, that looks like a difference of square. Oh, no, it's actually not. Like, that's totally normal to be thinking that way, because it's close. But what else do you see about it? It has a common factor. How do you know? Yeah, well, because they're both even numbers. You can divide 2 into both of them, right? 2 is an even number, 32 is an even number. That was one of the strategies we talked about yesterday. If everything's even, you can at least divide 2 out of it. So let's do that. We're going to divide 2. What's 32 divided by 2? 16. What's that? Now we do have a difference of squares. That's why it looked kind of like 1 and it was close, because once we common factored, then we actually do have a difference of squares. So I go 2. Actually, you know what I'm going to do? You can do this or not, but I'm going to divide both sides by 2. Because it's got a 0, I can do that. And the 2's gone. What's 0 divided by 2? 0. So I get x squared minus 16 equals 0. So this is x plus 4 times x minus 4 equals 0. So x plus 4 equals 0, and x minus 4 equals 0. X equals negative 4, x equals positive 4. Yes? No. Yep. What do you mean by any number? Yes, if it's equal to 0, you can do that. But don't do it if it's not equal to 0. Because there are other cases where it's not like this. But as long as you understand when you can and when you can't, you'll be fine. And it's useful, isn't it? If you can do that, it makes things simpler. It's nice.
So whenever we have a number out in front and the whole equation equal to 0, we can divide.
Yeah, if you common factor out a number like that in an equation equal to 0, you can just drop it. You don't even have to show that step. You can just, oh, that's gone. Get rid of that. But don't overuse it. Don't. People start being like, I can get rid of this, and I can get rid of this x, and I can get rid of that. Like, whoa, whoa, whoa. No, 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 no. Okay? There's only kind of one situation where you can do it. Remember I said there's 2 ways. That was one of the ways. Here's the other. Only do this if you like it and you understand when you can do this. This is the one type of quadratic that we actually can isolate for. Remember at the very beginning of the lesson where I said you can't isolate. Why can we not isolate? Because I've got x squared and x. Yes? But for this one, if I can find it again, I don't have x squared and x. I just have x squared. So this is one where I actually can isolate. 2x squared equals 32. I moved the negative 32 to the other side. Divide both sides by 2. X squared equals 32 divided by 2. Didn't we already talk about this? 16. And what's my next step? Take the square root of both sides. So x equals, and when you do that, you have to have plus or minus, right? Do you remember doing that? So x equals plus or minus 4. Same answers. Positive 4, negative 4, plus or minus 4 is the same thing. The danger of doing it with the isolating is you forget the plus minus, or you try to isolate when you're not allowed, because there's only this one case where you can do that. So be careful. Only if you really get this stuff would I say to use that method. You can always do a difference of squares as well. Any questions? Are we sure? All right, let's keep. Yeah. The next one looks different. What's different about it?
There's 2 terms.
There's only 2 things? Yep, very good. Huh? It looks like it's isolating, kind of. In other words, it's not equal to 0, is it? All the other ones were equal to 0. This one's not. See how we did isolating here? You cannot isolate this one. People will try. They'll divide both sides by x or something. You can't do that. You're not allowed to divide by x. You divide by 2, you can't divide by x. Yes! Beautiful, thank you. We get it equal to 0. Remember when I said it has to be equal to 0? Zero product property is the only thing that works. So move the 12x over and set it equal to 0. If it's not equal to 0, you make it equal to 0. Very good. What kind of a factoring question is that? Is it a trinomial? No. Not simple, not complex? No. Is it a difference of squares? No. It's a difference in its 2 terms, but there's not very much in there that's squared. So what does it have to be? It's common factor. It's the only thing that's left, so it's a common factor question. So I common factor out, in this case, a 3x, and I'm left with x minus 4. Folks, once you understand this kind of a question, it's like the easiest one, maybe. But for some reason, people misinterpret it, or they don't recognize it, and they make it hard and they get it wrong. Whereas it's actually easier, it's way easier than a complex trinomial factoring, right? It's even easier most of the time than simple. Okay? This means 3x is 0, or x minus 4 is 0. Divide both sides by 3. You don't have to show this step, but you have to remember to do it. So x equals 0, and this one is x equals positive 4. We have one more example to do. Is everybody okay? Ready to move on to the next, last one? What else? What's different about this one as well? Not equal to 0. So what are we going to do? We're going to make it equal 0. Very good. I'm going to move everything to the left. So I'm going to subtract x squared from both sides. And I am going to add 7x to both sides, and I'm going to add 7 to both sides. 7x squared minus 1x squared is 6x squared. 10x plus 7x is 17x. And then there was no constant, so just 0 plus 7 is plus 7. And don't forget, now it's equal to 0. Okay, I want you to try to solve this one. Figure out what type of factoring it is and factor it. Oh, folks, great job. Well done. Lots of people are done already. Maybe not everybody, but that's okay. So there you go. That's my solution. So I did my little table of factors over here. I figured out everything's positive, so that made it a little bit easier. 2x plus 1 times 3x plus 7 is what seems to work, because I get 2 times 7 is 14, and 1 times 3 is 3. 14 plus 3 is 17. Okay, and then again, like I said before, don't forget to do these last steps. So I got -1/2 and -7/3.